Check it.
Okay, welcome back. Today we're going to be talking about factoring, specifically factoring algebraic expressions. Now, factoring is something that you've done before where you took a number, or like 34, you could write it as the product of two factors, meaning 17 times 2. These are factors, and when you multiply the factors, you get the product. But let's say you had something algebraic, like for instance, x squared minus 2x minus 15. Factoring that into two things that are being multiplied is going to require us to learn some factoring methods. Now, there are 8 factoring methods that we're going to be learning this year, and today we're going to do the first 2, and tomorrow's part 2, we're going to do the next 3. And I will tell you that factoring is the single most important thing we learn in Algebra 2. Okay, let's just get into it. Now, the first one's called greatest common factor factoring, GCF factoring. Basically, if you look at an expression, do you see a factor they all have in common? 2x squared plus 8x plus 10. Is there anything you can divide all of them by? And the answer is yeah, 2. So what greatest common factor factoring is like undistributing something. So if you could pull a 2 out of each one of these, what would you have left? Well, you pull out a 2 from here, and now you have 2 times x squared plus 4x. So that's factoring out the greatest common factor. Now, if you want to check your work, all you do is distribute, okay? So when you do GCF factoring, you should check your work. You say, all right, well, if I were to distribute this back, do I get back 2x squared? 2 times 4x is 8x. 2 times 5 is 10? Yeah, and that's GCF factor. Now, here's the thing. The thing in here might still be factorable, in which case you have to continue factoring. We have to still factor this, and we'll learn how to factor this later in the class today. But the point is, just because you did one kind of factoring doesn't mean you're done. You have to keep factoring until the thing is totally factored. And the truth is, this is not factorable, okay? So I am done. All right, how about this next one here? What do all of these have in common? Well, you might say 3. 36 goes, 3 goes into 36, 3 goes into 15, 3 goes into 3. Yeah, but there's not just a 3 here. There's also an x squared in all of these, right? This has an x squared. This has an x squared in there. This has an x squared in there. So the greatest common factor isn't just 3. It's 3x squared. And then when you divide these by 3x squared, what do you get? Well, you divide 36 by 3, you get 12. And you divide x to the 4th by x squared, you subtract the powers, you get x to the 2nd. And now for here, negative 15 divided by 3, you get negative 5. And x to the 3rd divided by x to the 2nd, you subtract 3 minus 2, you get x to the 1, which is just x. And then 3x squared, well, 3 divided by 3 is 1. And then x squared divided by x squared is also 1. So there's nothing to write here except a 1 for all that. Now, let's check our work. If this is correct, when I distribute 3x squared back to these, I should get back this original thing here. So the way you multiply or distribute this would be 3 times 12 is 36. Numbers first, letters second. X squared times x to the squared is x to the 4th. 3 times negative 5 is negative 15. X to the 2nd times x to the 1st, you add the powers, x to the 3rd. And 3x squared times 1, well, 3x squared, because anything times 1 is itself. And you see that this checks out. So your answer that you're going to box, that was the check, but this is their answer right here, just not to be confusing. Now, we look at this here and say, can we factor this further? The answer is no, this isn't factorable. However, if it was factorable, you do have to continue. Just want to make that point on the homework tonight. If you just do one factor and then there's another thing that you can do, you have to do it. Okay, last one here. Is there a GCF in here? Well, 3 goes into all of these, right? So we'll put a 3 out here. Is there a letter that goes into all of these? And the answer is yeah. This has an A, this has an A and a B, this has an A and a C. So A goes into all of these. But what power of A goes into all of these? Well, this has an A squared, this has an A, also an A squared, and this has an A to the 4th. So every one of these has at least a factor of A squared. So we're gonna put an A squared out here. Then we're gonna put a set of parentheses big enough to hold 3 terms, 1, 2, 3. And then basically what you do is you divide each term by this. You undistribute the 3a squared from here. You get 12 divided by 3 is 4. A to the 4th divided by a squared is a squared. Now here, negative 9 divided by 3 is negative 3. The a squared is already there, so I don't have to do anything there, but times b. And now for this last one here, 6 divided by 3 is 2. The a squared is already there, so that's just going to be 1. You don't have to write that. And then c squared has to come down. And now this one's important to check if you're not used to doing this. Go ahead and distribute it. Okay, we're checking our work now. This is our answer right here, but we're going to check our work, and you really should do that. Well, 3 times 4 is 12, and a squared times a squared is a to the 4th. That one is good. 3 times negative 3 is negative 9. And a squared times b, they're different letters, so you just put them next to each other, a squared b. And then finally, 3 times 2 is 6. A squared times c is a squared c, because they're different letters. And yeah, that is correct. Now, it seems really easy and really simple, and it is. GCF factoring is the easiest type of factoring. Like I said, you're going to look in here and see if there's anything else that's factorable. You should always, always, always start by looking for a greatest common factor before you do any other type of factoring. Let's go on to a different method now. This next one's called, it's called trinomial factoring. I call it reverse FOIL. Now, what is FOIL? You might remember from Algebra 1 that if you have two binomials, bi means two, so two things in the parentheses, two things in the parentheses. You multiply a binomial times a binomial, you will get a trinomial, three things. You have the x here, you have a 3 here. You're going to distribute the x first, boom, boom. X times x is x squared, and x times negative 5 is negative 5x. And then you distribute the second thing, which is the 3 here, distribute that to both of these. 3 times x is 3x, and 3 times negative 5 is negative 15. And then you combine like terms. And you can see that in the middle here, these are like terms. Negative 5x and positive 3x are like terms. So 3x minus 5x is negative 2x. So we get negative 2x here. This is the same. There's no other like term for that, and this is the same. And there you go. That is what you get when you multiply this binomial times this binomial. Now, this means that x plus 3 times x minus 5 equals this thing over here. They are the same thing. They're just written in different forms. This is called factored form, and this right here is what's called the standard form of a quadratic. And now if you stick a y equals in front of this, you stick a y equals in front of this, you have this right here. Or you stick a y equals in front of this, which is the same thing, you can have this. And both of them are the same thing. They're both the same parabola. So I have a picture of that parabola in the margin here. This is y equals negative 2x minus 15. They're both the same equation, just written, one's factored and one's not factored. And what's good about factored form is that you can tell where this parabola hits the x-axis if you know the factors. If you know the factors, take a look. This thing goes through the x-axis at negative 3. There's a 3 here. That's interesting. And it goes through the x-axis on this side at positive 5. Hey, there's a 5 here, right? So it seems like if we have the factors, we can figure this out really quickly if we just know what to do with the factors. So why are factors useful? And what is the zero product rule? So let me talk about that for a second. The zero product rule is something that you would consider like almost like obvious, almost like common sense, like duh. If you have two numbers and you multiply them, you get is 0. Isn't it safe to say that one of those two letters has to equal 0? There's no other way for that to happen. In other words, if you know that something times something equals 0, either A is 0 or B is 0, or both. Both is possible as well. So that's the zero product rule. If you have two things or more, three things even, let's say you have A times B times C, and they equal, when you multiply them, you get a 0. Well, one of them, at least one of them, has to be a 0. That's guaranteed. So the zero product rule is pretty simple. If the product of two things is 0, or three things, or product of any number of things equals 0, then at least one of them has to be a 0. So how does that help us? Why is that obvious sounding thing super important and the basis for Algebra 2? Well, take a look. We have this parabola here. We factored it so we can see what's being multiplied. Okay, we did that in the last example. Now I want to find the x-intercepts. Now, hopefully you remember from Algebra 1, in order to find the x-intercepts of something, you have to make y equal to 0. And if you want to find the y-intercept of something, you make x 0. So if I want to find the y-intercept of this parabola, I'm at x equals 0. I'm in the center of the graph. So I basically make this x 0, this x 0. Those go away because they're zeros now. And what do I get? Y equals negative 15. So this has to be right here. This number down here has to be negative 15. Now, for finding the x-intercept, or x-intercepts in this case, there's two of them. They're right here and here. They're crossing the x-axis. You have to make the y 0. So now you have an equation that looks like this. So now we have this equal to 0. And you cannot solve this, okay? You cannot get x by itself when there are two different powers of x here. And we know that this right here is the same as that from the example we started. And now you can see we have two factors. Something times something equals 0. And by the zero product rule, that means that this factor might equal 0, or this factor might equal 0. This is your A, this is your B. So what you do is you assume that they're both equal to 0, you solve, you get your answers, and then after that you can check to see if maybe one of them is not right. That means that this creates a small equation here, x plus 3 equals 0. And this right here, x minus 5 equals, well, subtract 3 from both sides. Here we're going to add 5 to both sides. So we made the y 0, which means we forced ourselves to be on the x-axis, because this is where y is 0. When y is 0, you're on the x-axis. So we put in the 0 for y to force us to be on the x-axis, and then we solved. And we got x equals -3, which is what we have here, and we got x equals 5, which is right here. So this works. Okay, so we just used factoring to find the x-intercepts of a parabola. So basically, I call this reverse FOIL. Okay, it's not referred to that in any book or anything, but that's what it is. You're asking yourself, what would I FOIL to get this trinomial? So here's a different trinomial, and I want to factor it into something that's something times something. Now, we already saw that if you have two binomials and you FOIL them, multiply them, you get a trinomial. Well, now I'm going backwards, reverse FOIL. What are the two binomials that I multiplied to get this trinomial? So you always had an x and an x. You had some number, I'll just call it A, and some number, call it B. And then you distributed first, outside, inside, last, right? And you got your four things. And then two of them would always add together, so you ended up with three things. That was your trinomial. Well, for reverse FOIL, for factoring, you're going to start with the same setup here. In other words, write your parentheses like I just did here. Write your x's, because you're going to have an x here, or if it's a different letter like A or Z or whatever, use that letter. But start off with this. This is your setup. Now, the question is, what are these two numbers here? Okay, they could be positive or they could be negative. So this could be x plus or minus something. This could be x plus or minus something. So here we go. Here's how you do trinomial factoring. You set up your parentheses, you put down your x's, and then you ask yourself, what two numbers, A and B, would multiply to give me this, but add to give me this number here? So what two numbers, what A times B would be -21 when I multiplied them, but if I added A and B, would give me -4. So if you think about it, 7 times 3 is 21, so those would be my two factors of 21 that would work, but I need it to be -21, so it's either -3 and +7, or it's +7 and -3. Which of these two choices gives me a sum of -4? Well, 7 minus 3 is +4, but -7 plus 3, that's -4. That's going to be the one we're going to use. So put a -7 for one of them and a +3 for the other one, and there you go. That's factoring. And you might have seen this in Algebra 1, but just in case you didn't, that's how you do what I call reverse FOIL. I'm going to refer to it as reverse FOIL because basic trinomial factoring is a mouthful. So now that we know how to do reverse FOIL, let's solve an equation. Find the x-intercepts of this parabola right here. Like I said before, if you want to find the y-intercept, you make x 0. So the y-intercept is 10, okay? So right away, you know if you have a graph that the y-intercept is 10. What are the x-intercepts? Well, you find the x-intercept by making the y 0. If you make the y 0, you have this equation here. The problem is, looking at this equation, you can't tell what the x-intercepts are. What if we factor this? Then we can use the zero product rule. The zero product rule only works if you have some stuff on one side equal to 0. 0 is it's called the zero product rule for a reason. You need to have a 0 here. The zero product rule does not work if you have a 3 here, or a -5 or whatever. This has to be a 0. So let's factor this side. So ask yourself, all right, well, what would we FOIL to get this? Once again, start with x and x. What are two numbers that multiply to give me 10 that add to give me 7? Well, +5 and +2, right? 5 times 2 multiplied is 10. 5 plus 2 is 7, and they're both positive. Now, because I have something times something equals 0, I can use the zero product rule. Once again, you can only use the zero product rule if there's a 0 on this side here. So the zero product rule says I can set this equal to 0 and solve, set this equal to 0 and solve. And what do I get? Well, x plus 5 equals 0. You subtract 5 from both sides, you get x equals -5. And here you get x equals -2. So on my graph here, -2, let's say that's -2 for instance, and let's say that's -5. Those are my x-intercepts. So you can kind of see what's happening here. You have a parabola that's probably sitting somewhere over here, going up like this and going up like that. Just from looking at the equation, I can find 3 really useful points. And of course, since a parabola is symmetrical, whatever this is over here, there's going to be another point reflected on the other side here. I have 4 points on a parabola. That goes a long way towards graphing it, doesn't it? Right? I didn't have to make a table or anything. So finding the y-intercepts using factoring, incredibly powerful, incredibly useful, and pretty easy actually. All right, let's go on to the next thing here. Solve the quadratic equation. Hint, 0 is the hero. Yes, once again, you can't use the zero product rule unless you have a 0. Do I have a 0 here? No, I don't. I have a -1. So the first thing I need to do is I need the hero. Where's the 0? Okay. Well, how do you make this a 0? You get rid of whatever's here. This is a -1, so I'm going to add 1 to get rid of it. Now this becomes equals 0. But of course, if you add 1 to one side, you need to add 1 to both sides, right? That's how algebra works. So now I have x squared plus 2x plus 1. I have a 0 here, so this is a candidate for the zero product rule. If I can just factor this, then I will find my solutions. Well, let's see. Let's reverse FOIL here. Put down your parentheses, put down your x's. Okay, really, really simple. And now find two numbers that multiply to give me the last number in the trinomial, but add to give me the middle number. Well, what times what equals 1? 1 times 1? And what plus itself will give me also 1 plus 1 is 2. Yeah, that works. So that means I can set this equal to 0 and this equal to 0. Now, in both cases, I get x equals -1. So there's actually only one solution here. They're just the same for both. So your answer is x equals -1, and we got that by factoring, by the zero product rule. Let's solve this equation now. Once again, 0 is the hero. Do I have a 0 here? No, I don't. So I need to get a 0 here first. That's your first most important thing, is to have a 0 on this side. You cannot solve a quadratic equation unless the other side of the equation is 0. So let's subtract 20x squared from both sides. Well, this side is now 0, which is exactly what I need. On this side, I have 2x cubed plus 50x minus 2x squared. I'm going to put them in the order of descending power. So I'm going to start with the 2x cubed, that's the highest power. I'll bring down the -20x squared next, because it's the next highest power. And then the 50x will be the last power here. Now you look at this and go, okay, can I do reverse FOIL here? And the answer is no. Okay, reverse FOIL is not going to work here. And the reason why it won't work is because there's a greatest common factor. Ah, GCF alert. There's a greatest common factor that we can pull out of this. And then after that, I bet you this is going to be a much easier question so that you can use reverse FOIL. So take a look. What goes into all three of these terms here? Definitely a 2, right? 2 goes into 2x cubed, 2 goes into this, 2 goes into this. So we'll take out a 2. What about x's? There's an x cubed here, there's x squared here, and there's an x here. So we can pull out at least one x, right, from each one of these. Now what's left? Now this is GCF factor. Well, if you divide 2x cubed by 2x, you get x squared. You divide this by this, you get -10x. And 50x divided by 2x is just plus 25. This is still equal to 0. Write complete steps here. Do not take shortcuts. Now, remember I told you before, once you do the greatest common factor, you have to look in here and see if you can factor this. Yeah, this is definitely factorable. So your next step is to factor again, this time with reverse FOIL. Write a complete sentence here. I'm going to put down your x and your x. There are two numbers that multiply to give me 25 that add to give me -10. Well, yeah, it's either 5 times 5, give me 25, or -5 times -5, give me 25 when I multiply them, right? But which one gives me a -10 when I add them? It's got to be -5 and -5. So this is x minus 5, x minus 5. So now I have three factors. I know there's no parentheses around this factor, the GCF here, but you can pretend like there is if it makes it feel better. There are three factors here. And that means you can use a zero product rule, set every one of these equal to 0, and get your answers. Now, 2x equals 0. The only thing you can multiply 2 by to get 0 is 0. So this means x equals 0. X minus 5 equals 0. That means x equals 5. Okay, because you're going to add 5 to both sides. And this is going to be the same answer here, x equals 5. So since these are the same, you don't have to necessarily write them twice. Your answer here now is x equals 0 and x equals 5. And that's what you're going to box. Now, I'm all about, algebra is all about steps, not answers. So don't just, even if you can guess it, I don't care. I don't want to see an answer unless I see all of these steps. Because if this is a 3-point problem on a test, I will give you a point for this because you did the GCF factoring, and then this for doing the reverse FOIL factoring, and then 1 point for the answer. So if you just go straight to the answer, you're getting 1 out of 3. Make sure that you show all of your steps. This is Algebra 2. We grade steps, we don't grade answers. The answer is just the last step. Okay, so that's how this works. We factored twice, GCF first and then reverse FOIL. How about this one here? Solve the equation. Well, like I said before, you can only solve equations, quadratic equations, meaning having x squared in it. You can only solve equations if you have a 0 on the right side. So I need a 0. 0 is the hero. So how do I get a 0? I'm going to subtract 10 from both sides, 10x rather, from both sides. This becomes a 0 here. Now, 12x squared minus 10x, hopefully you realize that different powers of x are not like terms. You cannot subtract these, so just bring them both down. And once again, highest power to lowest. So 12x squared minus 10x. Now, you look at this and you go, all right, this is not a trinomial. Okay, trinomial factoring is when you use reverse FOIL. Trinomial, 3 things. This is a binomial, just 2 things. So you're not going to use reverse FOIL here. Just keep that in mind. You're not going to factor it with trinomial factoring. But there's definitely a GCF. And like I said before, always, always, always look for the GCF first. So GCF alert, we have, let's see, 12 and 10, 2 goes into both of those. So definitely a 2. And what else goes into both of these? Definitely an x. So what happens when I divide both of these by 2x? I get 6x minus 5, right? Check it. 2x times 6x is 12x squared. 2x times negative 5 is negative 10x. Yeah, that works. So now I'm here. And now, is this factorable? No, it's not. I can go ahead and say, all right, well, I have something times something equals 0. Once again, you have 2 factors here. This is a factor, even though there's no parentheses around it, it's a factor. And this is a factor. And if 2 factors equal 0, when you multiply them, then each one of them can be set equal to 0. So set this equal to 0 and set this equal to 0. We have 2x equals 0, so that means x has to equal 0. And now we have 6x minus 5 equals 0. That one is not so obvious, so let's write it down. 6x minus 5 equals 0. And we have to solve it, so add 5 to both sides to get rid of the 5. Then we have 6x equals 5. And then we need to get the x by itself, so divide this by 6, and we get x equals 5/6. Do not change these to decimal. Okay? So your final answer is x equals 0 and x equals 5/6. Box that, and you are done. And if you wanted to, you could plug these back into the original equation and check your work. You can clearly see that if you put a 0 here and a 0 here, this would be 0 equals 0, which is true. So that definitely works. And it just so happens that 5/6 will also work. All right, if you're in the academic class, you're done. If you're in the honors class, stick around for one more thing. This last thing is called writing quadratic equations from roots. So let's say I give you the x-intercepts of a parabola. Could you write me the equation? So for instance, let's say I told you that there's a parabola who has an x-intercept here at 3 and an x-intercept at 5, like that. And there are lots of parabolas, by the way, that could have that property. You could have a parabola that goes like that, or you could have a parabola that goes like that, or you could have a parabola that's upside down that goes like that. All of them have, oops, missed the thing. All of them have the same 2 x-intercepts. So there are an infinite number of parabolas that you could have that have these 2 x-intercepts. So you're going to write the equation of one of them. So how do you do that? Well, it's pretty simple. If you know, if you've seen what we've been doing all period, okay, all lesson rather, you know that your 2 factors, when you set them equal to 0, give you these numbers. So if you had a factored thing, you had some factor times some other factor equal to 0, and this would give you one, the zero product rule would give you one intercept for each. So this has to be x minus something, x and x. And you know that the numbers here determine what these are. You need to use a minus. It's x minus whatever the x-intercept is. And the reason being, well, you've seen it. Every time we do this, the signs flip, right? So this -3 right here, we're going to put it right here. And this +5 right here, we're just going to put it here. And now we have x plus 3, x minus 5 equals 0. If you solve this, you would get x equals -3, you get this intercept, and you get x equals +5, this intercept. Now, if you remember, we, in the earlier problems, whenever we wanted to find the x-intercept or x-intercepts, we had to make the y 0. We're doing this in reverse now, so the 0 becomes a y now. The only thing left now is to write this in standard form, to multiply this out, meaning FOIL it. So y equals, full sentences now, x times x is x squared, x times 3 is 3x, 5 times x is 5x, and 5 times 3 is 15. We combine the 2 middle terms, those are the only like terms here, and that is the equation of a parabola, not necessarily the only parabola, that would go through both of those points. So we have x equals -1/2 and x equals 4/3. Okay, so let's say that's -1/2, and let's say that's positive 4/3. Same idea. What would be a parabola that would go through those 2 points? Well, once again, your factors are going to be x and x, and this is the part you need to remember, minus and minus. And now just put these numbers in. So this is x minus 1/2, and this is x minus 4/3. And because these are on the, y equals 0, this would be your equal 0. And like we said, we're going to change that back to a y. And now if you could just FOIL this out, you're done. But in standard form, okay, standard form of a quadratic is, if you learn this in Algebra 1, is y equals ax squared plus bx plus c, only if a, b, and c are whole numbers, no fractions, and a is positive. So this is going to have some fractions in it. We're going to have to deal with the fractions. So this becomes y equals this, because the double negative here becomes a positive. And now you're going to FOIL. So x times x is x squared. X times negative 4/3 is negative 4/3 x. Then you're going to multiply this out here. 1/2 times x is 1/2 x. And 1/2 times 4/3, just multiply the tops and the bottoms. This is 4/6, which you can reduce to 2/3. Now, combine like terms. Well, actually, let's not combine like terms yet, because then we have to find a common denominator. Let's just go ahead and do the thing that we're going to do. So you have a bunch of fractions, and a trick for getting rid of fractions is to find the least common multiple of all the denominators and multiply by that. So what's the denominator on this first term? Well, it's 1. There's nothing here, so it's a 1. And this is a 3, and that's a 2, and that's a 3. What's a number that 3 and 2 and 1, but 1 goes into everything. What's a number that 3 and 2 both go into evenly? The smallest number they both go into evenly is 6. So if you multiply this entire equation, both sides, by 6, that's allowed by, algebra rules. So I'm going to multiply, just like with elimination, we're going to multiply both sides of the equation by a number, and as long as you do it to both sides, that's legal. Okay, so if I multiply both sides of this equation, I'll get 6y on this side. I'm going to multiply all of these by 6 now. This becomes, so I've multiplied all the tops by 6. And you can see that if you use the least common multiple, all of these are going to be whole numbers, all of them. Every fraction is a whole number now. So you get this now. And you can see that the two middle terms are like terms. You can add them together. Now, we get here. We're almost there. If this 6 wasn't here, this would be perfect. This would be a parabola that goes through those two x-intercepts. The thing is, you don't have a parabola until you get rid of that 6. But if you get rid of that 6, you're dividing all these by 6, you're going to create the fractions again. And we're not going to divide both sides by 6. We're just going to drop the 6 from this side. You usually can't do that. Okay, but the point here isn't to solve for y. The point here is to find an equation that works for those two x-intercepts, and the dividing by 6, okay, all it does is change the shape of the graph, but it doesn't change the solutions. So hopefully that makes some sense to you. This is the only time in all of algebra, okay, algebra 2, where you're going to do something to one side of the equation without doing it to the other side. I'm dropping the 6 from this side. In the book, they don't even use the 6 on this side, but I wanted to just explain that it's there and we're consciously dropping it. So we don't, to make a long story short, you're multiplying this side by 6 without multiplying the other side. And that's usually a huge no-no. But because we're looking for something that is just x-intercepts and we don't care about the shape of the parabola, that factor of 6 would only make it skinnier or wider. We don't care about that for this particular type of problem. So for the only time this year, I'm going to say, do something to one side without doing it to this side, the other side. And we are done. See you at the next video.
Check this.